The periodic table is made up of 118 different elements, all with different properties and uses. Some of these elements are widely recognized for the way we interact with them, but what about the ones we don't know? One of these more uncommon elements is antimony, represented by the symbol Sb. Although not the most famous element, antimony has been used since ancient Egypt when it helped create a form of eye makeup. Today it plays a vital role in our cell phones. This video will follow antimony from the Earth's creation all the way into the device you're watching this on. So let's start at the beginning. Where do elements come from? Well, millions of years ago, the Big Bang created the elements hydrogen and helium, the most abundant elements in the universe. But through a process called nucleosynthesis, dying stars and supernovas can create new elements. However, sometimes these elements begin as unstable isotopes, or unstable variations of an element. One process of antimony formation starts with one of these unstable isotopes. The supernova explosions and dying stars bombard the isotopes with neutrons, causing rapid process neutron capture. Once this process is complete, the stable antimony isotopes are left behind. But now that antimony has been made by stars and supernovas way out in space, how does it get into our solar system or even our planet? To answer that question, you need to know how both the solar system and the Earth formed. Our solar system started forming around 5 billion years ago. In space, a cloud of gas and dust called a solar nebula was pulled together by gravity, likely because of shockwaves from a massive exploding star. This material started to spin counterclockwise, becoming a flat disk called a protoplanetary disk, with most of the material staying in the center, forming the sun. From there, the planets were formed. When some of the hot gases condensed to form solid materials, gravity caused them to build up to larger solids. Compounds of elements like magnesium, calcium, iron, and silica condensed close to the sun and built up into terrestrial or rock-based planets like the Earth. When the Earth was formed, its composition was uniform, meaning the elements that made up the Earth were evenly distributed. However, we know the Earth now has multiple layers like the core, mantle, and crust. So how did this happen? Well, when iron is exposed to large amounts of heat or pressure, it becomes a very dense molten or liquid metal. Because of this density, iron and the elements found with it sink to the core. The elements that are left do not sink and stay to form the Earth's mantle. When the mantle partially melts, the Earth's crust is formed. This whole process is called planetary differentiation. But when the Earth's mantle experienced this process of partial melting, antimony went into both the continental crust minerals and the mantle. Now it is the 63rd most abundant element in the Earth's crust. So now that antimony is in the Earth, where is it found? Well, antimony gets its name from the Greek words anti, not, and monos, alone, because the element does not occur alone in nature. Antimony is typically mined in stibnite, a mineral containing antimony and sulfur. Stibnite is formed when volcanoes heat up the water inside the ground. This hot water moves through breaks in the Earth's crust, cooling as it goes. When these waters cool, they leave behind stibnite minerals, often with other minerals like quartz. Most of these deposits are found in China, with the Xiguangshan deposit in central Hunan being the largest stibnite deposit in the world. Other large deposits are found in Russia, Australia, and Bolivia. So now we know how stibnite forms, but how do we get antimony from it? Well, first we need to get the stibnite from the ground. The most common method of doing this is underground mining. Techniques used for this mining include room and pillar and cut and fill mining. Room and pillar mining refers to the process of making rooms underground with pillars of rock for stability. The stibnite can then be taken out horizontally. Cut and fill mining refers to the process of taking a slice of rock out of the ground and filling it back up to keep stability. However, when the deposits are found near the surface, open pit mining can be used. In regions like Myanmar and parts of Africa, small-scale open-pit mining is key in antimony production, but these operations often face safety and regulatory challenges. Once the stibnite is taken out of the ground, we can begin separating the antimony. The first step in processing antimony is crushing and grinding. After the mining, the ore is crushed and ground into a fine powder to separate antimony minerals from other materials. The next step is called beneficiation and concentration. When the crushed minerals are added into water, gravity alone can help concentrate the antimony in one place. When gravity is not enough, a process called froth flotation is used. This process involves using a chemical to make antimony particles water repellent. This allows them to float to the surface for collection. The last step is smelting. This process involves heating the concentrate and adding in coke, a coal-based fuel, to isolate the antimony. So now we have antimony. What do we do with it? Well, antimony functions as a semiconductor. These semiconductors are used to produce transistors which act as switches or amplifiers for electrical systems. This is essential for the function of a cell phone. Antimony can do this because of its low diffusion coefficient. This means that antimony molecules diffuse from areas of high concentration to low concentration relatively slowly. This makes antimony more precise and stable, the ideal for a smartphone. So next time you use your phone, just think, 5 billion years of work went into it.